Okay. Oh. Yeah. Sorry about that. So identification is basically a general term for getting what you want. And in the causal relationship context, it's basically about whether you can get a causal relationship or not. Okay, so if one does say stuff like this causal relationship can be identified, then you're basically saying that this person is basically saying that one can actually obtain causal relationship between variables. I know this is a little bit vague at this point, but I'll explain that concept in more detail later. So don't worry about it if it doesn't make sense. You mix it too much together. Good. And then there is this thing called estimation. In the world of identification, it's all about theory and whether you can identify a causal relationship or not. It's all about theory. There's no models, just theoretical world. And in the estimation, it really comes down to the real world and then what is observed. Okay. And a common way to approach to this estimation issue is using a regression model. Good. So you are using a regression model to investigate the relationship between gender and wage. And then you're estimating the coefficient. Basically. Does that make sense? Yeah. Yeah.
Regression is for estimation, not.
Oh yeah. No. Regression is a way of estimation. Yes.
Okay.
Yes. Good. Yeah. Yeah.
So when we're talking about identification, we're talking about the theory of
Right. Identification is a more theoretical concept, whereas estimation is actual estimation of numbers. So you all will learn more about this thing called DAG.
Yeah, data mining.
Oh, wait.
Sorry, data mining.
Oh no, not data mining. DAG, which is acyclic graph, directed acyclic graph. That is, you're going to learn more of that in this class actually. But that is related to this issue actually. While learning DAGs, like a lot of students got confused with the differentiation, like subtle difference between identification and estimation actually. So it'll be much clearer when you learn DAGs and then how to use DAGs to really estimate what you want. But for now, my point here is that you should differentiate what is really going on, a theory of data generating process, and the estimation part. You should conceptually differentiate these three situations, and then you should be able to distinguish these situations, but connect these situations in a coherent way. You're going to learn more of that later. So let's just lead this differentiation at this stage. Okay. All right. In the second lecture, we talked about potential outcomes framework. Okay. So according to the lecture, this is the framework of causality in modern statistics. Right? It really is summarized by this equation: yi, y I0 plus yi1 minus yi0 ti. Okay. So yi is observed outcome. Okay. And this means potential outcome upon I treated, not treated or controlled. Good. And yi1 is potential outcome upon I's treated. Good. Right. I'll explain what it means by this equation. So when ti is 1, which means the observation I is treated, yeah, then ti becomes 1, right? Then yi becomes yi1. 1, it means 1, then they cancel out each other, and then this is the 1. So if we assume ti is 1, then the observed outcome is the potential outcome when this person is treated. When ti is 0, then yi becomes yi0. Right? So you are thinking about two situations. The first situation is when the person got treated, and the second